Hi everyone, I'm Professor Casey, and thanks for tuning in to part 2 of the Strings lecture series. Today, we're going to talk about string functions, and specifically some of the more detailed string functions you can use when you encounter strings in C. Let's get started. Alright, like I said, we're going to be talking specifically about some of the detailed string functions you can use to manipulate strings in C. Quick review. What's the difference between a char and a string? Remember that a char is just one individual character, and a string is a bunch of characters together inside of an array. Why do we use the null character? The null character tells our print or our putS where the end of the string actually is. So when we go to print it to the standard output window or to a file, we know where to stop printing at. And lastly, because this is really important and it's a really common error when you start learning about strings and you do string assignment for the first time, why when I write something like this will it not work? If you watch the bonus video, hopefully you know that I'm trying to actually assign a string to a pointer. Remember, the name of an array points to the beginning of the array in memory, the address of the first element of the array. If I wanted to assign this to hello world, ! I'd have to do it when I actually initialize the string at the very beginning. So I'd have to put hello world up here on this line with the equal sign. Okay, let's talk about our very first string handling function. This string handling function is string copy, strcpy. String copy. It takes two different arguments. What it's going to do is it's going to take string 2 and copy it into string 1. When it does that, it takes the null character off string 1 and adds it to the end of the full string after it copies in string 2. Okay, so let's look at what happens when we use string copy as an example. I've declared s. I want to copy in hello world into my string s. What happens when I do that after I run this line of code? I get s equal to hello space world ! With the null character added on the end. String copy is specifically for chars, so it adds that null character for you. How about string len, which stands for string length? I want to know how many characters I actually have inside of a string. This goes through your entire string and counts everything up to the null character. It does not include the null character as part of the count of your string length. So let's look at an example. If I have s again, I've declared n as just a regular integer. I want to copy hello Bill into string s. Okay, so it's going to copy all of these characters in there and it's going to add the null for me, remember, because it's a string function. Now I've set n equal to string length. So I'm taking the string length of s, this string that I copied hello Bill into, and I'm going to print out n. What number is actually going to print here? Go ahead and pause to take a guess yourself. It prints out 10. Now, why does it print out 10? Because I have 10 characters inside of the string here, not including the null. The null would be 11. So when I declare my string, I have to make sure it has at least 11 characters available, but my string length doesn't include the null, so it only prints out 10. Okay, before we get to string toke, let's look at some examples. Alright, so I want to show you some bad examples here. Hopefully if you were paying attention in the first video, you already know that this isn't going to work. Why is this not going to work? When I build this, I'm going to get an error, right? And it's going to tell me I have an error with my array type in line 7. That's because in order for this to work, I actually have to have this up where I declare my array, right? Because this s is actually a pointer. This is a pointer to the start of the array in memory. So instead of doing this, I need to do something like this, right? I could have simply done this, and if I build this, this should now work. Perfect. Or, because I want to illustrate how string copy works, I could do this. I want to copy hello world into s, and if I put ss, it's kind of weird to say, if I put s, my string, it should print hello world to my standard output window, because that's what putS does. So even though I'm printing out S, it copied hello world into S for me, and it prints it out just fine. Let's also look at an example of string length. So again, I have my string declared, I have int n. I'm going to copy hello Bill into S. Okay, so that copies in the null character with that, 11 total. But then when I run a string length function on S, it's going to return an integer. I'm going to save that integer in n. And I print out n, it should print out 10. And it prints out 10 because it doesn't include the null character. So just remember that you have to catch the value this is returning with an integer variable. Okay. Now let's talk about tokenization. What does tokenization mean first? Tokenization means we're parsing things out. We're trying to break something down into individual components. What this means in a string function is that we're taking a sentence, a full string, and dividing it into its words. The words are the tokens that make up the sentence. Now, this doesn't always have to be words. We can separate a string by spaces, for example, but we could also separate a string by any other character that we want. And this could be a period, or it could be a semicolon, or it can be anything. Whatever you decide you want to separate it by can be the tokenization character. And let's look at an example of this. So here's my string. I've declared it up here. I have some random punctuation in here, a couple spaces, just so we can kind of illustrate how this is going to work. In string 2, I've declared my tokenization character. So this is what I'm looking to separate my string by. So a space is the most common. You're separating a sentence into actual words, but I could also have others. Now I have to have a temporary string, string 3, that I declare here, because when I tokenize this, it's going to start breaking pieces off. So it's going to say, oh, this is the first string. Now I encountered a space. So I'm going to store this string, everything before that space, into string 3. Then I need to print string 3, and then I need to set the null character. And then I need to do this all again until I get to the very, very end, until I get to that final null character. Now, how do I know when this while loop is going to start? This null will get copied into string 3 as soon as I run out of things to check. So that's what this code is actually doing. So let's go ahead and run this and see what happens. Remember, I'm running it with this initial string here. Now we're using a space as our tokenization character. So it looks like it worked pretty well. I'm going to separate hello and goodbye. I'm going to separate this period from yes. I'm going to separate this period from is, and these 3 words from each other. So this separates out into 6 different words as part of my sentence. Okay, well that's good to know. What happens if I want to use multiple things as tokenization though? Maybe I also want to be able to separate things by this comma or by a semicolon or something else. In that case, I can actually use multiple tokenization characters. And I just put them all in one string together, and it will go one by one and do these. So I have a space here, a comma, a semicolon, and a period. And let's see what happens when I run this same code on this same sentence, but using multiple tokenization characters. Now I get 8 total words, because now I've separated each individual word, even that yes, no, maybe, which is only separated by semicolons and commas, and I've separated them all out. So you can use tokenization with any character you want, even multiple characters, to get the individual elements of a string. And this can be really useful, especially in data entry. We talked about string copy already. Remember that this copies from the source into the destination. You can also have the function string n copy. And what this does is it copies from the source a certain number of characters. So let's say I don't want to copy this entire string into my destination. I only want to copy the first word. So I might say int 3 or int 5 or whatever, however many letters I want to copy into my destination. So if I have this char s6 and I want to string copy the first 3 letters of hello into S, I have HEL. Now when I'm using string ncopy, this is different than string copy because it does not add the null for me. Right? It does not add the null. You have to do it manually only when you use string ncopy, only when you separate it by the number you want to. We also have strcat, which stands for string concatenate. Now, if you don't know what concatenate means, it basically means combine, put together. So I have my source and I have my destination, and basically this means add the source to the end of the string that exists in destination. So maybe I have a word here and a word here. This would just add whatever word is in source to the end of the word in destination. It writes over the null that's in here and adds a new null to the end in my destination string. I can also do string ncat, which means I'm adding only a certain number of the words from this string onto the end of destination. So let's do an example. Let's say I have a string called Social Security. It's 12 long. I also have strings SSN short, SSN 1, 2, and 3. You can feel free to pause this at any time so you can try these on your own. Store in SSN short as much of Social Security as will fit. Okay, so the first thing we have to figure out is how much of it will actually fit in SSN short. We know we have 7 here, but we also know what about strings? That the last number, the last character, inside my string will be the null character. So I actually only have 6 that I can use to store in SSN short. And what that will be is the first 6 characters. 1, 2, 3, 4, 5, 6. This hyphen is actually a character, it gets included. So to do this, I'm going to have to string copy from the beginning of Social Security into SSN short. And how many I'm going to have to copy? 6. The last thing I have to do is I have to remember to add the null character. Now I already copied 6 in here. Why am I copying the null into the 6th element if I already copied 6 in? Remember, array elements start at 0. This is where things can get really confusing and you can start chopping off parts of your string that you didn't mean to chop. This is actually the 7th element of the array because it starts at 0. This is the last element. Just always make sure that last element has the null character. All right, B, store in SSN1 the first 3 characters of Social Security. Okay, so I'm going to take the start of Social Security, copy it into SSN1, and we need to do that for just the first 3 characters. Now we're using string ncopy, so what else do we have to do? Right, in the last element, we have to add the null character, just like in this first one. Okay, now a little bit of a challenge. We want to store the middle 2-digit portion of Social Security, so the 4-5, into SSN2. So we know that the first part will be string ncopy. We know that this second part will be SSN2, right? That's what we want to copy into. How do I know where my source is? How do I know where to start? This is where knowing about arrays and memory will really help you. We have to start at the address of the 4th element. What does that mean? It means I go to the start of my array, right? Social Security, the name here, the address of the start of the array, and go 1, 2, 3, 4. And from there, I want to copy 2, which will copy the 4 and the 5. So whenever you need to copy something in the middle, you have to use this special array notation where you have the address and then the element number after the address where you want to start. And again, we're using string end copy, so what do we have to add at the end? Never forget to add that null character, that's important. The last one, right? Try and do this one on your own before I show you the answer. Again, we're going to use string end copy. We have to say where we're going to start. Remember, start of the array, go 7 elements in, then copy 4 of them into SSN3. The last element always has to be the null. I will post the code for this inside of the Blackboard site, in case you want to check yourself. Okay, another example. Let's say we have this string. We've declared it as 20 and we call it Prez Adams, comma, John Quincy. We've also declared 2 other strings, first and last. All right. So we want a string copy from Prez into first 2. All right, so that means the first 2, AD, will get copied into first. And then the last element of first has to be the null character. So what's actually going to print out when I print this string? Should be AD. All right, now this is a challenging one. Let's look at this. I want to copy from my source the address of the start of Prez 7 elements in. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. 7 elements in, I want to copy the rest of it, which will end up being John Quincy until I get to my null. Okay, let's try another example. String copy into first, starting at ampersand Prez 7. I only want to copy 2 things, and I add my null. What's going to print for this one? Right, since I'm starting at 7, it's the first 2 letters on this one, J-O. Now, starting at element 14, I also want to copy 2 and store them in last. What's going to copy here? In. And remember, since these are string end copies, I have to add the null myself. If we print both of these strings back to back, what are we going to get? We get the word join. Okay, another check. Let's look at this. Into temp 1, we're going to copy from ampersand Prez 7, right, the start of John, and we're going to copy 4. Then we're going to add our null character. Okay, so that should give us John with a null at the end. But then we're going to string concatenate a space onto the end of temp 1. Okay, so now we get John with a space. The next section we have string copy from Prez into temp 2, 5 letters. And we add our null on. Okay. So that should give us Adams stored in temp 2. And now we want to print it as one full string. So we're going to concatenate temp 2 onto the end of temp 1, which should give us John space Adams. Okay, let's talk about another type of string function called string compare. String compare takes 2 strings and compares them via the ASCII table based on their differences. So this will take 1 letter at a time from left to right and say, are these 2 letters the same? And then it'll go to the next letter and it'll say, are these 2 letters the same? And it'll keep going. Once it encounters a difference, if it does, if the string S1 is less in the ASCII table than S2, right, less numerically in the ASCII table, it returns a negative number. If string 1 is positive, is greater than S2 alphabetically or from the ASCII table, it returns a positive number. And if they're the same, it returns 0. And I always try and think about that as meaning 0 differences between them. You can also do string end compare like you can with many of these string functions and only compare a certain number of characters between the strings. Some other useful things as we're talking about ASCII table, we can convert any string that we want to a float numerical conversion. We can also convert it to an integer, and this actually stands for ASCII to float and ASCII to int. So you can convert a whole string to the numerical equivalent if you would like to. Okay, so let's look at this example. Go ahead and pause this video and try and figure out what each of these will result in. So go ahead and pause now, and then I'll show you in code blocks how this actually is going to run. Okay, so I have the exact same code here in code blocks that was on the slide. Hopefully you took a guess. All we're doing is the string compare between these two strings. When we go ahead and run this, check this with your answers. If we compare ABC Jones in all caps to ABC Jones, we get -1. Now, why do we get -1? That means that this value numerically is less than this value numerically. Well, if you look at the ASCII table, uppercase letters come first. So A, B, and C in both of these will be equivalent, but as soon as it gets to this J, it notices, oh, this one is a lower number on the ASCII table than this one. So it knows to return a -1. It doesn't even look at the rest. How about this one? JONES to JANES. Okay, so the J's are equivalent, then it gets to this O. This O comes after, it's a bigger number than A, so since S1 is bigger than S2, it returns a +1. Jones to Joneses. Through this point, right, everything's equivalent. But then we compare nothing, right, it has no more letters, so 0, to a positive number, and that means S1 is going to be less than S2, which returns a negative. JAZZZ to JOAAA, it actually doesn't even get to this last portion because as soon as it sees this A and that O as different, it knows, oh, this one comes first, this is going to be less than this. How about J compared to Jones? Well, if you look on the ASCII table, you'll see that lowercase letters come after uppercase letters. That means when you just compare this one feature, this will be bigger than that one. There's nothing to compare after that, so you get a 1. And dog to dog, just like we talked about, lowercase letter to uppercase letter here, you're going to get a positive number because this is bigger than this. Okay, pop quiz. Quick example, quiz yourself. Which of the following function calls would run some fun only if the string values of the character arrays of A and B were equal? So which of these options will run the function some fun only if A and B were equal? Only if the string A and the string B were equal. Take a guess real quick, pause the video, see if you can figure it out. Okay, the answer is going to be B. We have to check, right? This function returns 0 if there are 0 differences. If we do A, which I'm guessing some of you guessed, we actually return 0 because they would be equivalent. But if we have an if 0, are we going to do anything in our if statement? No, that means our condition is false, so we jump down below our if statement. So this wouldn't actually run it. Only B is the way it will actually run, because remember, anything our condition has to evaluate to true to actually run. Okay, a quick review of everything that's inside the C-type library. So this is for initial characters, just individual characters. We can analyze individual characters to see if they are a letter, a space, or a punctuation mark. We can do this in C, and I'll actually show you an example of how to do this. You can convert things to upper and lowercase. Remember, this is for individual characters only. And using strings, these are inside the standard library as well, you can convert ASCII to a float, or some sort of string in ASCII to a float, and a string in ASCII to an integer, and get the total numeric characters for the whole number. Okay, so last example here. I'll walk you through this, and I have it in code blocks too, and we'll run it there. I've declared a string of unknown length, and I've said the rain in Spain. And when I declare this like this, where does the null character go? It adds it for me. It adds it right on the end for me inside of memory. Now I'm going to have this loop. And this loop is going to go until my total string length, right? It's going to go up until I get to my total string length S. All right, so I convert SJ, whatever element I'm at, so we start at R, to upper. I do a put char, that means I print it out on the standard output window. I print a space, and then I check just this one character, right? If it's a space, I'm going to print space character. If it's a punctuation, I'm going to print punctuation character. And if it's an alpha, I'm going to print letter character. And you'll notice I'm doing this with put S as an example. And then I'm going to print a new line, and then you go in increment J to the next character. The next character we do would be A, etc., and we'll go through the whole thing. Let me show you. All right, so example 19. You'll see in order to use those, I have to include my C-type library for the is space is punct, and to use strings that put S and get S, I have to use string.h. So don't forget your libraries. This is the same code that's on the slide, so let's just go ahead and run it and see what happens. It should go character by character, right? It starts at R, tells me it's a letter character, gives me a new line. Then it goes to A, and it's converting all these to upper just to illustrate that that can work and how to use them. It tells me when I have a space character, right? And it tells me when I have a punctuation character. And it knows when to stop because I used string length. So as long as J was less than string length of S, it knew, okay, I don't even have to look for the null character. I know when to stop. Okay, the very last thing I want to touch on. Some of you in 106 saw this. Some of us touched on it, but I don't think everyone did, and I just want to highlight this because this is a really, really common use for strings. If you remember in the example I did earlier when I did my file pointers, I had an input file and an output file. I actually just hard-coded my input file and output file. I called them input.txt and output.txt, and I did that when I opened them right here. I just put in double quotes input.txt, and here I put output.txt. If you don't know what file you're going to enter, or if it's possible that you may enter multiple files, you can actually use something called dynamic file naming, where you don't have to specify. You can have the user enter the input and output file names, and then yes, we are using a scanf here, scan them in because we want them as two separate strings. If you don't want them as two separate strings, you can use getS and do two of them. We can scan them in as two separate strings and save the first string as in file and the second string as out file, and then it will actually read those when it goes to open it. It will automatically skip the null at the end. So you can actually have someone specify which files they want to open by just typing those in. They do have to include the extension, the .txt or .csv or whatever. But if they do it correctly, you can actually specify whatever file name you want without having to hard code it into your file. So this is a really, really common way to do file conventions when we open things, and it's kind of a bonus topic to cover. All right, thank you for tuning in to part 2 of the strings lecture. We talked about specific string functions for handling, tokenizing, and manipulating strings using the C-type and string.h libraries. If you have any questions, feel free to comment below on this YouTube video. You can also shoot me an email or your professor an email if I'm not your professor. Again, I'm Professor Casey. Thanks for tuning in for part 2 of the strings video series, and I hope to see you soon.